Okay. Can everyone see my screen? Just wanted to make sure.
Yes, yeah, we can see your screen.
Okay. Okay. So I'll just, as per our standard, I'll just quickly walk through the question and then we'll give like 10 minutes so that the team can, everyone can quickly think through how we can come up with a solution. And then we will discuss like, what are the different ways. So this find peak element. So here the question is like the peak element is an element that is strictly greater than its neighbor. So we can take one sample. So the input is, we have an array or integer array. So in this integer array, we need to find out the peak element. So in this example, if you see that 1, 2, 3, 1, if you take any specific element and if either the left and the right is smaller than that particular element, then we can consider that as a peak element. So that's pretty much, that's the question, or that's the thing that we need to find it out. So given an integer array nums, find a peak element and return its index. So the output that we need to give is that specific index. So if the array contains multiple peaks, return the index to any of the peaks. So in case the second sample we can take, for example, in an array, if we have a multiple peak, here the question is like we can return any peak, either from the first or from the last, or any one is fine. You may imagine that nums of -1 equal to nums of n equal to minus infinity. Here, I didn't get very thoroughly, but my understanding is your lower bound and your upper bound can be infinity. So so there is no restriction, or there is no specific limit on what is your lower bound or what is your upper bound. And then here the in case if anyone wants to add in any other points, you can add in here. You must write an algorithm that runs in O log n time. So here, that is one requirement, that we need to write a solution in an efficient way. And then we already looked at this sample. So if you take look at 1, 2, 3, 1, if you take this element, you don't have any left bound. Sorry, you don't have any left index. So you can just look at the right index. So compared to the right one, this is still a lower. So we cannot take this as peak. And now you can take 2 and you can look 1 and 3. Is that really higher? No, right? So when you compare the left one, it's still a peak, but when you compare it with the right, it's a small one. But if you take these 3, 2 is higher and 1 is higher. That's how you need to find the peak. The same thing is applicable to this example also. We can go one by one to find out what is the peak. And is there any question, or if anyone's not clear what is the problem is, I can try to explain.
So just one question: if second element, that is a element with value 2, if that is 0, in that case we can consider 1 as well the peak, right? The first element.
Yes. So you are right. I mean, let's say we'll take one sample. For example, this descending sample, right? If you take 4, 3, 2, 1, and let's say you are looking at the first element and you are comparing, because you don't have any left, but you can compare with your right. So compared to your right element, your current element is big. So this is definitely a peak, and you can return out of it, which means we can return this element and we can say this is peak and our work is done. So it pretty much based on the data set, but this is one of the case. And the same thing can happen to an ascending also, which means here you can take an assumption. If the input set is sorted, and let's say it's sorted in ascending order, then definitely your peak is going to be in your nth index or in the last index. If it's in a descending order, definitely your peak is going to be in the 0th index. And there is one more sample set. I think that as per this constraint, this may not be applicable, but I've seen it like some cases. Let's say if your input array is kind of all of them with the same integer, then potentially there is no peak. But what we could potentially do is like, the final one is what we would return, considering that as a peak. And yeah, and the other scenario is like, somewhere in the mid, there's a chance like either it can be start or it can be in the end or it may not be, or it can be anywhere in the mid.
Sorry, what did you say for the third scenario when all the elements are equal? What is the peak here?
When all the elements are equal, I think towards the end we go and we return the final one.
Okay.
But yeah, I think here they are saying this is not a proper case. Here the reason is like, if you look at this constraint, nums of I not equal to nums of I plus 1. So definitely when you look at this, this is, let's say if you take a nums of I and if you take a nums of I plus 1, these two should not be the same as per the constraint for all valid I. So they are saying like always the neighbors will be unique in a way that you will not have a duplicate neighbors. That's my understanding.
So they have given the strictly greater than its neighbor. So I don't think that is the valid case.
Yeah. When I was looking somewhere in some cases it showed, so I added that, but for this case that constraint is not possible. So, and then if we look at other constraints, when we look at that, the maximum nums length, the array length would be from 1 to 1000, and each I believe that nums of I values can be from minus 2 to the power 31 to 2 to the power 31 minus 1. This, I think, pretty much the element or the integer in an array can be like, can go from kind of a minus to plus as what they mentioned. Yeah. Anyone have any other questions, or before we take time to look, try to write some solution? Yeah, we can take some time, but I mean, we can try to write kind of a brute force kind of approach, which means like a linear search. We can try to think in a way that a read through in a loop, look for, that is one approach. And then there is kind of a efficient one that also you can think of. But the first approach would come in and like O of n, I believe. So it's kind of not as per the expected question, but we can try to write that, and we can think about that, and then how we can write a efficient one to get O log n approach, O log n time complexity. Now time is 10:14. We can connect around like 10:24. Is that fine?
Yes, Deva.
परत सांग. हा.
Yeah. Shall we discuss? Let me start sharing my screen. Yeah. Anyone wants to add any thoughts? How we can proceed this, or let's say if you wanted to go with a linear approach. Anyone have any thoughts, or anyone wants to share what they tried or anything?
I think linear approach is just we just go to the each element and we check left and right. And that way we will figure it out whether this element is peak or not, if both the left and right are smaller than the current element.
Okay. But the question is, do we really need to check both left and right, because we are checking from the left and we are moving forward, right?
Yeah.
I think, yeah, go ahead.
No, sorry, go ahead.
Yeah, like if you hit a peak, I mean, if you picture how a peak looks like, the next element should be less than the current element, right? So you could just look forward and then say like, okay, the next element is less than the current element, so the current element is a peak.
Yes. Yeah, so my thought is also pretty much we don't, I mean, for the first 0th index, we have no other go, right? I mean, we don't have any either left, or we are going to just look at the right. But going forward, I mean, from there, we don't need to look at the left, right? We can just look at the next index and see if that is a less, then my current element is a peak, right? We can return that index and we can close the program. Is that right?
Yeah, so the 1, 2, 1, 3, 5, 6, 4, right? So it would look something like this, for example. So if we have a peak here, let's call it 1, 2, 1, 3, 5, 6, and then 4. So pretty much if you just check the next number, and if it's less than the current number, we know that we hit a peak at that point.
Yeah. Yes, yes. So so if we need to write the logic, it would be like we do one loop and then we look at the current and the next and see if the current element is smaller, right? Then
Right. So if the current element is larger than the next element, then we know it's a peak.
oh yeah, yeah.
I have a question. I don't know if it's being discussed, but what if last element is 6 itself and there is no 4?
Yeah, in that case, let me do the annotation one more time. So let's say we have, are you saying we have something like that?
Yeah, that's also possible. Yeah, that's also possible. Yeah,
Yeah.
that's
So
that's a worst case. Yeah.
Yeah, so in this case, 6 is your peak, right? You reach the peak at the end of the array. It's like one of those edge cases where, let's say you hit the end of the array, and this turns out to be the largest element, then you would just return this as the largest element.
yeah. And the other way it can happen like this also in a descending array. Then in this case, your 0th element is your peak.
Right.
Yeah. I was just thinking, what did you just mention about 0th element? Like if it is 6, 5, 4, 3, 2, 1, like first element is a peak, then what's the logic? I mean,
Yeah, so this question pretty much asks like return any peak, right? So
yeah.
if you have something like that, for example, we saw a peak right there, so we return this. So it could be something like that, right? Then you could still return this as a peak according to the question.
Yeah.
Yeah, because I think we never found an element bigger than 6 while iterating through array, right?
Yeah, and also they say that you could just return any peak. It doesn't have to be the highest peak, right? So if you just see the condition where the next number is smaller than the current number, you just return the result. That's what the question asks for. So
Yeah.
so here, the one I was referring to here is indexed to any peak. So
Yeah. I can quickly run through the program. It's written in Java, but the same O of n approach. Yeah. So this is pretty much what we looked at the sample, right? So here the main key condition I've seen, like we are doing one loop.
Deva,
Yeah.
sorry to interrupt, but I have one question. So, which index should it return when if the last two integers are same, like 6 and 6? Then what should it like? Which index should it return?
I think it will end up, for example, let's say if it's like this 1, 2, and 6 and 6, right? That's your question. Eventually, what it will do once it finds the peak, let's say if it's in the first index, which is number 2, and what it will do, it will find out the 6, right? And if n is less than,
I think this will be the invalid case. If we just check the constraint 3,
oh yeah,
it's saying number 5 is not equals to number 5 plus 1 for all valid I.
you're right. Yeah.
Okay, got it.
So all
yeah,
the consecutive elements should not be the unique ideally.
Yeah, got it. Thank you.
Yeah, thanks, Satish. So yeah, anyone have any other question before we just walk through the code? Yeah, so here, like basically what we are doing is like we are looping in, and mainly we are checking whether the current element is greater than the next one. So if the current element is greater than the next element, then definitely it's a peak. So we are returning that particular index.
I think we'll get array index out of bounds for last index when I will be equal to nums.length minus 1.
Yeah. Yeah. So usually the boundary condition, what we do, we go as like, 0 to length, but here the case is since we have I plus 1 involved. So here we are looping through till I minus 1, sorry, length minus 1. So definitely this will not end up in. So this is usually when we write other for loops here, like, it's we are kind of terminating prior to that end index. So this will avoid the array index out of bound exception.
Right.
Yeah, so this is O of n, kind of a, yeah, from the complexity perspective, like, O of n, since we are running through the whole loop, so it would be O of n, and the space complexity wise, it's a constant output, so it would be O of n. And anyone have any other thought process? There is one more way to get O log n. But I tried to write by myself, but I couldn't think of. But anyone have any thought process, like, we can solve this through binary search to bring the efficiency of, like, O log n. But I have a question. Like, I'm also not sure. Like, I was not. Usually, if we really wanted to solve anything by slicing it and then in a smaller group, chunk it up, and if we find what the solution that we wanted to look at, we can go with the binary search, right? How we can apply this in find peak element I mean, anyone have any thought process how we can, this is the problem, but how we can apply that binary search algorithm into it?
I think at any point of time, we have to move towards the larger element. That is our neighbor. So I guess at any point of time, we can check both the element. If both the element is smaller, we got the output. This is the peak element. But any one is larger, then we can ignore. Let's say right element is larger, then we can ignore the left part, and we can move towards right. So that way, we will definitely find the peak element. So this is what I thought.
Yeah, that's pretty much the approach is like, we are going to take a mid element. For example, in this one, we would take a mid element and then see for that particular mid element, whether it is going in an ascending order or descending order, right? Then our search should go or move towards where the ascending goes so that we can find the peak element. So in this case, but is that right? Like, the binary search can be applied only for the sorted array?
No, that is not a
No.
true statement. I
No.
guess there are many cases where we can apply without sorting. We just need to identify if there is any condition which can, with which we can cut our input into half. If that condition is matching, like we found such conditions for all the input, then I think we can leverage the binary search. It's not necessity that we have to have the sorted elements.
Hi Deva, am I audible?
Yes, yeah.
Yeah, so actually I sent one video in the chat which is by MIT, and I think what you're asking, that approach is basically the professor has basically given there in the video. So if you go to 11th minute timestamp.
Okay.
Yeah. So yeah, from here I think he explains, or maybe in comment you can see from where this is. There are two approaches given by him, and I think for this there is optimized approach as well, which has been again discussed in this video. So if time permits, we can see this video, or maybe we want to see it offline, we can do that as well.
Okay.
Yeah.
I think I've written the solution also, but in case if anyone have questions or anything not clear, then we can take a look at that also. So I'll quickly walk through this question. So it's a generic kind of implementation of binary search, right? We set two pointers. One is which is the starter pointer, and the other one is the end index. And then what we do is, like, this is our basic boundary condition. If the start is less than end, we keep on looping. If it goes beyond, if the start goes beyond the end, then break the loop and come out. And then now we are starting to slice it. So we need to find the mid. So here we are just summing up both start plus end and divided by 2, and then we are finding the mid. So this is our regular condition, as like, I see it here the same way. So we are finding it out whether the mid element is moving towards the ascending way. If it's in an ascending way, then we go towards to that and find it. For example, if your mid, definitely if the mid is greater than the next element, then your ascending is going towards your left, because your peak is going to be in the left. So we are moving our mid to end, our end to mid, so that our search case is going on the left hand side. If that's the other case, then we are moving start to the mid, so that our search case is on the right hand side. This is my understanding. So then it goes on chunking it up further based on it reaches the base condition, and then it will find it which one is going to be the peak element.
So Deva, this looks great. I just have a question. I don't know. I mean, I'm not expecting the answer from you, but in general. So the thing is that, let's say, this looks correct if we assume the array is sorted, right? Like, say you said, if it's decreasing, move towards the left, right? That's what we assume. But let's say, since the numbers are random, and we have found like mid is greater than mid plus 1, right? So we expect the peak to be on the left side, right? But
Yeah.
let's say if there is some random peak like 1, 2, 3, 5, and then 102, but there might be some bigger element on the right side. Even though we target to move on the left side, but there might be some bigger element on the right side, right? You see my
So,
question, right?
the
Yeah.
question is asking any pick. It is not asking for the bigger pick. So if we
Yes.
just get any of the pick, that is fine.
Yeah,
That
if
makes
it
sense.
would be
Yeah.
if it would be the first peak, I think this solution would not make sense. But since, like, if we want to do it in O log of n time, I think this approach is suitable. That's what I understood from the video.
Yeah. Yeah. I do
So
have the
I
same.
think that's correct actually, because it's I think the trick is just finding the first peak, and either way you go, whatever peak you find, you get it, right? I
Yeah.
think that's the trick. So either you go left or right depending on what number. So even let's say if the array is not sorted out, right? Depending on what you find in the middle, that's, let's say it's a destiny of the array, right? Whatever you find. Now you either you decide to go left or right. You can have peak both the side, right? Or maybe not, right? So either way you go, and whichever way you find the first peak, I think that should be the answer, right? Because that's what question says, the first peak.
Yes.
So now in the same lines, if you consider that to be any peak, right? Now, this condition right here, it says nums of mid is greater than nums of mid plus 1. So if we plot these points, it should look something like this, right? So why are we still looking towards the left side? Because we're going to the left because end is mid here. Why can't we just return the result here?
Yeah, I think we can return after, if like end is equals to mid, we can return mid straight away over here. No need to slice it more, since
No, what
we
I
got
mean
done.
is you could
No,
just return mid as the result, correct? Because
Yeah,
nums of mid is greater than nums of mid plus 1.
no, but what if nums of mid minus 1 is greater than nums of mid? So this will not be the peak, right? So this, then our answer will get like we will not be get the correct answer. So we can't return it in if condition. You
Gotcha.
got my
So,
point?
for
Yeah.
example, it would look something like this.
Yeah, I mean in left it keep increasing, left
Okay.
side. Yeah.
Makes
Okay,
sense.
yeah. So in that case, maybe it could be element 0, in which case we need to return that. Okay. Or it might look something like that. All right. Yeah, makes sense.
Yeah. Yeah, that's pretty much from the solution side. Yeah, I do have some questions, but if we have like, what if they ask some other variations, like, what if they ask find first peak or last peak or find all the peak counts, something like that. But I think definitely we may not be able to use the binary search approach, right? In case if they ask us to find the last peak or first peak.
Yeah, I think binary search will not work in that case.
Yeah.
We have to go
Yeah.
linearly or some storage
Okay.
or something like that.
Okay. Yeah. Anyone have any other question? Then I think we can jump on to the next one.
Just a quick question. So what did we ended up in concluding? The question when we were somebody asked like if mid is greater than mid plus 1, then at that specific moment itself we can return, right? I think somebody asked that. So what did we conclude on that?
What we concluded is like, there is a chance in the left hand side, still in the left hand side, there is a potential chance it could go in an ascending order. So we really need to want to find it out. Is that the real peak? Because at any point of time, even though the right is lower than the left, but there is a chance that the left neighbor could be max. So we need to find out, is that the real peak or not?
So it would look something like this, for example. Your mid plus 1, and I can't write this, and then mid is here, right? What they're saying is you could have any point to the left of mid that's still the peak. So you need to set your endpoint here and then do the binary search here. Good.
Okay, yeah, that makes sense.
Okay, yeah. Let me stop sharing. Satish, you wanted to share the screen?
Deva, I had one request. In the question, you had like some questions or maybe some variations, right? This 4 questions, like, could you please post along with the solution as well?
Yeah, sure.
Sure, thank you.
Yeah.
Yes, Deva, I can share my screen. Can you please confirm you can see my screen?
Yeah, I can see your screen.
Yeah, thank you. So here's a quite interesting problem. So the question is, we have to find the container with most water. So let me just read through the problem first. So basically we have given an n non-negative integers a1, a2, an, where each represents a point at coordinate I, comma a of I. Okay. N vertical lines are drawn such that the two endpoint of the line I is at I, comma a of I and I, comma 0. Find two lines which together with x-axis forms a container such that the container contains the most water. Notice that you may not slant the container. Okay, so let me just try to explain what they are asking. So they have given us one array, and the value of each array will represent the height of the height of the bar. We can assume like this is a bar. So if first element is 1, which indicates that our first bar is height of 1. So you can see this is black one is height of 1. Then the second element is 8, which indicates that second bar is height of 8. Then next is the third element, which is 6. So this indicates that we have a bar of height of 6. So this way we will build like we have this kind of a bar, and we have to identify the what maximum amount of water that we can store between the bar, or like 2 bar we can consider it as a container, but just to understand it simply, we are taking it as a bar. So our our goal is to find the maximum water that we can store between the any two of the bar. So here, let's just go through with the answer. So here they said answer is 49. So how it is 49 is, so in this case, they have considered this two line. This is with height 8 and with height 7. So maximum water, like height of the maximum water will be 7. And the width will be 1, 2, 3, 4, 5, 6, 7. So 7 into 7, which is 49. So this is the storage that like maximum water that we can store with volume is 49. So this is just one example. You guys understood the question? Any doubt? Okay, I'm assuming there's no doubt. So let's take a just go through with the input and output. So here the second example we have given is 1, 1. So we have like two bar with height 1 and 1. So our the maximum water that we can store is height is 1 and width is 1. So which will be 1 into 1. So answer is 1. In the next question, next example, they have given 4, 3, 2, 1, 4. So in this case, I guess, yeah, the height will be the left 4 and the right 4 will be the maximum width, which is 4, and height will be also the 4. So 4 4 just I guess, yeah. 16. Yeah, that's the correct answer. And let's just go through with the constraint. So n is equals to height dot length. Value of n is, I mean, number of row at max will have 10 raised to 5. And at any point of time, maximum height can be 10 raised to 4. So this is the input. Everyone understood the question? I think this is quite complex to understand. So if anyone has any doubt, then we can discuss right now.
So quick question. So the question is like, we need to find out which container which stores the maximum water, right? I mean, there's a potential chance that we may have a multiple containers may hold water, but we need to find it out which one holds the max. So we may need to.
Maximum. Correct.
Okay.
That's right. So let's take an example. Let's take, we have just 8, this one, the second one, and 6. So what will be the maximum water if we just consider this as a container, the height with 8 and height with 6? So the maximum water that this can show, width will be 1 because this is the 1, and the height will be the minimum of 8 and 6, which is 6.
6.
So
Okay.
6 into 1. So this 2 will consider can store only 6, I mean volume with the 6. Let me just draw it out. Yeah. So if we just consider, I mean, this as a container, so this will store the 6. Let's say if we take this as a container, so this is the height is like left wall has a height 8 and right wall has a height 7. And the width is 1 and 2. So this will be, sorry, the width is 2 and the height is minimum of 8 and 7, which is, this is 7.
Yeah.
Yeah, so 7 2s are 14. So this is the maximum water that can store in this container is 14. That way we have to maximize the maximum container, the maximum height that we can store, maximum water that we can store.
Okay. Yeah, this makes sense. Yeah.
Yeah. So let's think till 8 o'clock. I mean, sorry, 6
Yeah.
o'clock.
Yeah.
And we'll discuss later the solution. Can we start now? Okay, so let's
Yeah.
begin. So anyone has any solution, any suggestion, how we can do this, how we can solve this problem?
I had a thought on like traversing an array and having minimum and maximum. So every time we check nums of I and I plus 1, and out of those two elements, we have our minimum. And then for maximum, we have we can take max, and whatever minimum we had, and then the maximum, which was like retained, it was initially 0, and later on it would be updated. So I think till now I would be getting max. So I would be getting the level wise maximum level of or height of container. But then I was giving a thought how I can multiply that, how I can give thoughts on multiplying or distributing that height um, um, between container width. So I think, yeah, I needed time for that. But yeah, this was the approach I thought initially.
So I didn't get like what you are storing. You are storing the maximum height at each array, something like that.
Yes, maximum height of an container or array. Yes.
Something like at any point of time, this is 8, Z, Z, something like this.
I'm not seeing your screen. Are you sharing it?
Okay, yeah, sorry, I'm not sharing my screen. Can you see my screen now?
Yeah.
So this is our input array.
Yeah.
Right. So what you will store here, 1.
Yeah, it would be 1.
Then this will be 8.
No, what I was thinking, we have 1 and 8, so we would be checking with the consecutive element, which is 1 and 8. So minimum would be 1, because we need the minimum container cannot retain the maximum height water, right? If the one side is less. So we would be taking minimum, and we would be having maximum as one more variable. So initially it would be 0. When we go to a second element 8, and we would be comparing against 6, right? Here we would be getting minimum as 6, and then maximum would be comparison of like what minimum initially was and what exactly I have now. So the maximum for third element would be like 6.
Maximum for the third element will be 6.
6, right? Because we would be comparing 1 and 6. We go to 6 and 2, minimum would be 2 now.
Okay.
And we would be checking against max. Initially it was 6, and now it is 2. So the max would remain same. Now we compare 2 to 5. The maximum minimum would be
2 to 6, right? 2 to 6 or no? It's
2
to
to
6.
6. Yes.
Okay,
Yes.
2 to 6.
Yeah. Then for 5, it would be again like we would be comparing with 5 to 4, and the minimum would be 4. Maximum still in this case remains 6. We move to 8th element. Not sure if it is making sense, but
no, actually, I didn't. I mean, I am not getting what you are calculating. So this way, we are just calculating the however, like whatever we can store between two consecutive container. We are getting something like that, right?
yeah. So basically, what I'm doing here, I was thinking if we can have the height of the container, the altogether height, and then we can multiply it with like I think we might need one more variable to basically check like from where we have to retain that water, if I make sense.
Okay, you are like to calculate the width, right? You are saying like
Yes,
what is the width?
now
What
we
is
have
the
got the height. Now we I think I need some
but
variable or
I
something.
still don't get. I mean, let's say for the 8, I mean, this is the height of the container. At this point of time, we are saying we like maximum we can store is 6.
No, if you go to last element of array, right, it is 7. So I think in between 3 and 7, yeah, there won't be any comparison between 7. So I was thinking with this logic, I wanted to check, like, basically the height of container, but I think, yeah, this won't work.
Yeah. And I was like in the same direction, we can think of like storing whatever on the left side, like maximum towards left side. So at any point of time, we check what is the maximum height to my left at this condition. Let me just draw that out. Okay, so at this point of time, I will check what is maximum left height I have. So it is nothing, so it's 0. At this point of time, I will check what is the maximum left height I have. This way we will check it's 8, I guess. Yeah. So we can calculate that, and same way we can start calculating from here. What is the maximum towards right? It is nothing, so 0. Here it's 7. Here maximum to the right is 7. So this way we'll calculate the whatever is the, and we take the minimum out of height towards left and to the right, and then we can calculate. I think that might work, but I haven't thought in that direction that you are saying. But okay, anyway, let's start thinking in the. Let's first think about the brute force approach. How we can do that.
Okay.
Yeah. So I think for brute force way, we can consider, like, we can first take this as a height. I mean, wait, I'm not able to draw. Anyway, yeah. So we can take we can start from, let's say, for the first element. Any idea how we can draw hand-free? I mean, what should I select? Yeah, I think this is good. We can start from the first height. This is the first left height of any element, and then we can iterate to all the right elements, saying what is how much water I can store between 1 and 8. So it will be minimum of 1 and 8 into difference between index, that is 1 minus 0, which is 1. So it will be 8 into 1. In next cycle, I will check how much water I can store between 1 and 6. I mean, between 1 and 6, this much. So it will be minimum of 1 and minimum of 6, which is 1 into whatever is the weight. So here weight is 2. So it will be 1 into 2. So this is like maximum I can store is 2 volume of water. Then I will check with 1 and 6, this one. So here minimum is 1, and width will be 1, 2, and 3. So it will be 3. So this is 3. So this is the brute force way that we can iterate through each and every element, and we can just try out all the possibilities, like how much water we can save, and then we take the maximum. So this will be big of n square time complexity. Everyone got the idea, like what we are doing?
Yeah.
Okay. So that is the first way. And the next optimal approach for this, we can think. So the basic idea is, at any point of time, if we have two pole, this, let's take example of this and this. So how much water we can store is minimum of first and minimum of second. So maximum we can store is the minimum of both the height. So in this case, this will be the minimum. If I'm okay, let me just rewrite again, rephrase it. So let's take example of this height and this height. So at any point of time, if I wanted to find out how much water I can store between this height and this height, so it will be the minimum of this one and this one. So the height of this is 8 and the height of this is 3. So the maximum volume, well, I mean the maximum height is minimum of 8 and 3. So our height will be 3, because minimum of 8 and 3 is 3. So this is the height. And width we can calculate by just finding the index of this and this, and we can subtract it. So index of this is 1 and index of this is 7. So it will be 7 minus 1, which is 6, into height that we have calculated into 3. So this is the basic idea behind how we can calculate. Everyone got the idea about the minimum part, right? How we can store the minimum amount of water.
Yeah.
Yeah. So this is just the idea. So now we have to calculate maximum water that we can store. So in this case, we can take a 2-pointer. Let's say the first one is it here. Let's left pointer that we can start from the index 0, and the right pointer we start from the end of the index. So this way we can start iterating one by one. And so I'll just first walk through about the idea, so that way you will understand how this is working, and then we can calculate. So let's assume this is the left pointer is at height 1, and the right pointer is at height 8. So maximum water that we can store is maximum height can be minimum of 1 and 8. So value is 7. So 1 and 7. This is the height 1, and this is the height 7. So maximum that we can store is minimum of 1 and 7. So this will be the height of the water that we have stored, and the width is between width of the water that we have stored will be whatever is the index of first element and left pointer, and whatever the index of the right pointer. So in our case, the index of left pointer is 0 and index of right pointer is 8. So it will be 8 minus 0. So this is minimum will be, this is our height, and this will be our width. So this is the case. So here, if we just consider just this as a left boundary and this as a right boundary, then maximum we can store is, this is the width, which is in our case is 7, and the height will be this only, this much, 1. If we this is the thing that we can store between first and last boundary. I mean first and last rod, we can say. So this will be our maximum water that we can store in this case. So here the constraint, if you just think, what can be the constraint? How we can increase the water height? So this is only one way. We have to increase the height of this left rod basically. So to increase the height, there will be only one option. We can move towards the right. So that way, whenever we find out, if at any point of time, if we have two heights, let's say this is the height 1 and this is height 2, so we will always increase the height which has a minimum value. So in our case, the minimum height is at index 0, so we have to increase the index 1. So in an upcoming cycle, what I will do is I will increase the left pointer, and I will put the right pointer the same at height 7 only. I know this is quite complex problem. It is quite complex to understand, but everyone got the idea what we are doing?
Yeah. Yes, Satish.
Yeah. So here at this point of time, our left is here and our right is at this index. So if we just check what is the height of our left rod, it is 8, and this is the height of the right pointer. So in this case, the maximum height of the water will be minimum of 8 and 7. So if we just check what is the minimum of 8 and 7, it is 7. And the width of this water will be the value of right pointer, index of right pointer minus index of left pointer. So in our case, this is 8 minus 1, which is 7. So width will be 7, and height is minimum of 8 and 7. So it will be something like this. That is already painted that is already shown in diagram. So that will be 7 into 7. So if we just check this as a index, then it will be 49. So this is the max value that we have, maximum water that we can store it if we consider the index 1 and index 8. So this is the case, and now we have to think about which pointer should be moved, whether we should increase the left pointer or we should decrease the right pointer. So since our minimum value between those is 8 and 7 is 7, so we have to maximize our water. So what we'll do, we will move towards left. We will decrement the right pointer. So our next time, this will be our left, and this will be our right. So this is 8 and this is 3. So if we just check what is the minimum of 8 and 3. Okay, so we have decreased the right pointer. So right pointer is at 3. I'm just writing on top of that. So we will find the minimum of 8 and 3, which is 3 in our case, and we just subtract width will be 7 minus 1. So it will be 6. So it will be 3 into 6 will be our, I guess our answer will be 18 in this case. So since it is not like we found maximum is 49. So we'll just keep on calculating this side and this way until left and right pointer is left and right pointer are crossed to each other, the normal 2-pointer way, and we maintain the max variable, and that way we'll calculate the answer. So let me just go through with the code first, and then I will take the doubt if you guys have any. So this is the I've written it in Java. So this is the max area code. Here we initialize max area is 0, then left pointer is at index 0, and the right pointer is at the end of the array, which is max height dot length minus 1. And we iterate till left is less than equals to right. I mean just a normal 2-pointer way. And we first calculate max area. So max area will be mat.max area, and we have to identify the minimum height of left and right pointer. So this is our height, minimum height, and this is our width, because we have to for calculating width, we are just subtracting the index of right and left pointer. So this will be the width of the water that we are considering right now, and this will be the height. So we are just maintaining max area, and at any point of time, if we say, let's say left height is smaller than right height, then we increase the left pointer. We have to calculate, we have to go to find the maximum height. So that's why we are just incrementing the left pointer. And if any point of time, if my left pointer is bigger than the right pointer, at that point of time, we just decrement the right pointer. So this is the basic idea of this problem. Any questions?
So I just wanted to add in the thought that the max area calculation is pretty much same between the 2-pointer approach and the and the brute force approach, right? And then we are doing the the optimization, which is the if and else, right? That's where
That's correct.
Wherever
That's
it
correct.
is less, we are incrementing. That is solving, giving us a good optimal performance.
Optimize, yeah.
Okay.
We are in just one traversal. We go through the basically we are reducing the combination in the case. Yeah,
makes sense. Yeah.
So the time complexity in this case will be, I guess, big of n, and we are not storing anything, so that way space complexity will be 0. I mean, with constant space complexity. Anyone has any other doubt? I mean, it is kind of a complex to understand, but like once you know the trick, it will be very easy.
Just wanted to add in, it may not be a right question, but the better one, we found out that in brute force, the time complexity is O n square, and then it's O of n.
Mm-hmm.
Is it possible to do it in log n? But I really don't know if it is, because it's container based, right? I'm thinking like the binary search can be applied, or because the binary search scenario was like a specific thing that we wanted to find it out, right? But here it is like we need to look at the container kind of approach, right?
Yeah, makes sense. So I think log n will not be the possible, because we have to at least iterate once to each and every height, because there is no way we can identify saying whether like by considering log n scenario, we will not be able to come up with the solution, because we have to at least go through the ones to the each and every heights. So yeah,
Okay.
binary search will not work here. And ideally,
Okay.
generally binary searches work when we have some condition where we can reduce the choice to the half. And I don't think there is any way we can do that in this problem.
Okay. What if, I mean, just potentially throwing, I don't know if, if there is any, I'm thinking like, what if they ask like, hey, give me a second max or third max? I mean, from the top, find the lower second or third. Am I asking the right question?
Yeah,
In case if
yeah.
they put a variation
Mhm.
like that,
Mhm.
I mean,
We can introduce the heap in between. So we keep
okay,
adding the max area into heap. Let's say if you ask me to give a fifth max, so I can maintain the heap with size 5, and I will keep adding max area into the heap. And whenever the height is increased, I just delete it. So that way, at the
okay,
end, I will get the fifth maximum container volume.
okay, okay, got it.
That is just one optimization that I can think of right now. We can introduce heap in this case.
Okay, got it. Yeah, thank you.
If we are good, then I think we can go to the next question, Deva, or we want to just close the session today.
Yeah, I think it's already 11:22. I think, and moreover, our next question is rotate array. I think Meta. I'm just looking. So we can, if everyone is okay, is it okay to stop here? Like, I think the rotate arrow and palindrome linked list, we can take it tomorrow.
Yeah, we can do
Is
that.
that fine with everyone? Okay. Okay, I think, yeah. And Satish, I just wanted to check with you, like, will you be able to post that, the text also, like, that when you were explaining that you did the calculations, right? That was very clean to understand. If you could post that also, would really help.
Sure. I will do that. Yeah.
Deva, actually, I had one suggestion, or maybe we can look for a solution for it. Yesterday, I updated recording for the yesterday's yesterday's questions. So what we can do, whatever or someone is sharing screen, we can have one txt attached in the Excel sheet for particular, like every question, and in that way the code is accessible. Because in WhatsApp, I think
Yeah,
the
I think
code is
organization will be like will not be able to organize a solution for each and every
yes.
problem.
So
Yeah.
if I want to go back and like access, for example, I really liked the approach, or maybe follow-up question you brought up today. So if I want to go back like a couple of weeks later, I think that would be in that way, I think organized, if we can put it in an Excel sheet. Just a suggestion, or maybe
Yeah, definitely.
Yes.
So I'm thinking, is there any site link we can take? Like, sometimes Lead Code provides a rough draft kind of thing, right? We can copy that code and we can put a link over there. But I will, if anyone have any suggestions, right? Like, we can copy the code over there and we can put that link.
I mean,
so
I
that
think
that
the GitHub is the best way, I guess. We can just create the file in GitHub and just
that's
copy paste it and just put that link in front of the Excel. That will be the
yeah,
easiest way that I can think.
exactly. Yeah,
Or
that's a
can we
nice
add
thought.
txt? I think in the drive, right? We can have folder called as code base, and probably we can
But
have.
Asha, I guess in GitHub we can also maintain the version if anyone wants to improvise later.
Yes, absolutely. The GitHub
Uh,
would be always like a good choice,
yeah.
but like
And
that was
you also don't have to clone it locally. You can directly on browser only. You can just create the file, copy paste the code, and it will be hassle free.
yeah.
Makes sense. It's a good thought. Yeah. So I'll look at it to see, if we can create one public project or something, right? And then we can start placing. At least we will start from today onwards. Like, what we have, the code base we have.
Yeah, I can do that. And I also like personally I'm maintaining my repo on GitHub. So yeah, I will just create one more repo.
Yeah.
For
Sure.
discussions.
Yeah. Thanks, Satish. Okay, then I think pretty much we are good. Yeah, shall we stop here now and then we can join tomorrow? So I'm thinking tomorrow we will review rotate array and then palindrome linked list. We will see if we can stick with 30 minutes, but I think yeah, we'll think. I think maximum 2 items takes like 1 hour, right? Or sometimes 1 hour 15 minutes.
Yeah, I mean, I think in one session I like on an average we can solve 2 problems.
Yeah,
Like
yeah,
yeah.
yeah. I mean, is that the 10 minutes that we are giving, right, for writing or trying? Is that helping much, or like maybe we'll discuss tomorrow, at least to narrow down. But I think at the same time, this will be helpful for other members to just to try it out, right, for 10 minutes.
Yeah.
Yeah, but we'll
Let's
discuss this.
yeah, let's discuss tomorrow when
Yeah,
Sagar
sure.
in.
Yeah,
And
when
we
Sagar
can,
is in.
yeah.
Yeah, sure. Yeah, thank you all.
Thank you, everyone.
Yeah, thank you all.
Bye.
Thank you. Bye.